Okay, we have now all working. We have brakes, we have turn signals, we have the lights turning on and off. Let's add some more spice to it and create the braking rotors, which will be heating by the parameter setup. So let's open our wheel and check the material which we have here, which is the brake rotor carbon ceramic. Let's open this material and let's go to the parent, like master material. So here we can add the function which will make our brakes heat and emit light. So first, by holding number 3 on the keyboard and clicking on the mouse, we will create the parameter for the color. Let's make it really saturated red orange color, something like that. And now let's multiply that by the value which will be defining how much emissive light we will be producing from our heated brakes. So right click here and click promote to parameter. Name this parameter heat. Nice. Now connect it to emissive color. Let's use our parameter heat and put it into the group of base color. Click apply and save. Now let's switch back to our rotor. If we increase the heat, it looks really strange because the whole material is becoming red, but we don't want that. We want our material to be also showing those lines, and to do so we need to just grab the roughness map. The thing is that the brake rotor uses this metal wear lines roughness map. There are 3 channels like red, green and blue, and we can pick the one which we like to basically mask out what we don't want to use for heat and what we want. So we need either green or blue channel. I'll be using the blue one. So let's go to our master material, and there is already roughness mask prepared for us. So let's do it this way. So we will disconnect this for now and create another multiply node. And let's connect the blue channel here to multiply. And the result of our emissive color and the heat value, we will connect here to the multiply node and to emissive color. And hit apply, save, and let's see how it works now. So if we increase, see, we still see those wear lines, even though our brake is emitting light. So if you see that on the car, you can see that there are lines still there, the cracks are there, and it's emitting light. Now we need to control this parameter over in the blueprint to being able to animate that, not putting each time in the sequencer. So let's reset this one, save this material, and get back to our blueprint. So now we need to create the function, actually 2 functions for this particular brake heat. So let's create first the function for brake heat creation. So here we will create the function for creating the dynamic material and store that function. I'll explain why a little bit later. So let's start with grabbing front left and front right wheel, because I believe only front wheels get the most of the pressure and they will be only heated. You can do this for or 4 of them, but currently we'll be doing for 2, but you can do that for all of the wheels. So what we need to do is to create dynamic material instance. So create dynamic material instance. It will switch the material which is currently assigned and will create a dynamic instance which we will be editing later. Unfortunately, you can't plug both of those components into this node, so you would need to create and duplicate this node, basically copy paste it. So the material element index is, let's check on the front wheel, it's number 1. So material index will be 1. Let's copy that and paste. Here we connect the target, we'll create this one. And after that, we need to store this value into the variable. So we need to create the variable break front left, and that should be dynamic material instance object reference. Put it here, set, duplicate this one for the right one, right, and that would be for the right set. You need to connect those pins, and what it will do, it will create this dynamic material instance once, and if we put this function into the event graph, it will be creating the dynamic material on each tick which can affect your performance. So we just need to create this once. Let's drag it here. So this script will be running only once in the construction script, because when you start the simulation during the render, it will perform the construction script only once, but we need the construction script for previews also. So this one is the creation. Right now we need the different one for editing this material. So we create another function, name it break heat modify. And now we can take both of those material functions, like we stored that in the variable, the material, dynamic material instance. And from each one, we need to set scalar parameter value 1. And we now here can connect to both of them, because the parameter name is the same. Parameter name is heat here. So we type it here and connect it like this. So now we need to create another parameter which will be modifying this value, right? Let's name it break temperature. Let's create a new variable, name it break temp. Make it a float, because we are going to scale this value. The default is 0. Let's connect it and set the slider range from 0 to 3. I think this would be enough. After that, we need to go to construction script and add break heat creation. We'll create this material, and then we'll use break heat modify after that. In the event graph, we would need only the break heat modify here. Connected there. Compile, save, and let's see how that works. Oh, before that, make sure that you make this instance editable and expose to cinematics. Put the break temp in the car setup. These materials can be hidden. We don't see them. And we are not going to touch them anymore because they are not for editing. And basically here you can now see, you can edit the heat amount of the brakes for both of them, right? And now if we create the sequence like that, where we have the brake temperature, it will be working. And if we go into simulation mode, it also will be working here. That means it will be working in the render. Now our car is ready for animation with all the functions, with the turn signals, with the daylights and additional brake lights here, for example. And all of that can be done in the sequencer. So it is completely ready for animations.